So I accidentally just emailed myself that it was starting, so I'm gonna give it a couple more minutes. So I'm gonna change this to from 4:25 to let's say 4:30. Just about 5 minutes from now, and then we'll get going. Hi Jack, hop on Fort. No, I'm good. It's like you went from being really addicted to watching the World Cup to addicted to Fortnite. It's funny how that works. You can come on whenever he wants, but I'm gonna start in the next couple minutes, so make sure to tell him that. I didn't realize I CC'd an email with everyone on it, saying that I was gonna do one of these, and then my next email, which is when I was gonna start, I just hit reply, and I hit reply just to me, so I just sent myself an email about when I was gonna do the review. Um, so here I am. But hopefully people will start kind of filtering in. I've got this and then honors pre-calc to do in like an hour or so. I don't think this one will take very long. I think the first three are going to be the longest problems, and then everything else should be just about fine. I also figured out how to work the music without you guys hearing it, which is really nice. I normally do it, but I guess I had on the last one I did, I had like my desktop audio on, and I didn't realize it was not muted. So for like 10 minutes, I had the same song on repeat, which I didn't. I thought that was a normal thing, just to have one song on repeat for like hours at a time, because that's how I can work. But that's not normal, I guess. All right, we'll get started in the next like 2 minutes. So do what you need to do, and then I'll get going. Okay, we'll go ahead and get started. Um, I'm gonna do this kind of differently than I did the last two exams or the last two tests, I think. I'm just gonna go through these step by step, and as you guys have questions, you're gonna ask. So normally, what I have is like the notes out in front of you. I kind of walk through those real quick, and then I go through every section. I'm just gonna go through them as we go. All right. So as you have questions, please ask. Also, if you can't understand something I write, like I'm hoping this looks big enough. I kind of I made the actual like PDF document like this thing as big as I could. But if you can't see something I write, let me know. I haven't had any complaints about that, but just to make sure. So I'll go and get started. Um, the big thing here is kind of actually taking derivatives. That's the only new thing that's on this exam that wasn't on the others. So questions 1 through 3 says use the limit definition of the derivative to find the derivative of each function with respect to x. So just take the derivative. And I have that definition right here. Right, so the definition of derivative says that the derivative of f, this f prime of x, and just so we're clear, that's not f to the 1, that's f prime. I had a couple people ask about that. That's the limit as c approaches 0, right? C is a little step to the right or to the left. So the limit is c approaches 0 of f of x plus c minus f of c. That should be f of x. All over c. So in the end, we're going to have to divide something out because we can't take a derivative of something in indeterminate form. But we'll cross that bridge when we get there. So that's the limit definition. For number 1, we're given y, or f of x, it's the same thing, is equal to 3x squared minus 3x plus 2. So we need the limit as c approaches 0 of f of x plus c minus f of x all over 2. Okay, so that's how we set that up, and our job is to just kind of FOIL out, simplify, cancel out as much stuff as we can, and that's not a 2, that's a c, like that. Okay, so then we have the limit as c approaches 0 of 3 times x plus c squared. X plus c squared is x squared plus 2xc plus c squared, and then minus 3 times x plus c. So minus 3x minus 3c plus 2, and then subtracting all this stuff. Then we have the limit as c approaches 0 of 3x squared plus 6xc, right? This 3 is being distributed, plus 3 squared plus 3c squared minus 3x minus 3c plus 2 minus 3x squared plus 3x minus 2 all over c. Okay, now as kind of a, not a warning on the test, but just as a kind of a, I don't know what I'm going to call it. Anyway, I'm kind of interweaving a bunch of these subjects into one. Okay, so taking the derivative, that's going to require you to take limits in certain ways that we've already tested on. So like dividing out, rationalizing, all that stuff, that's going to show up. It's just not going to show up as like explicit, like single problem. It's going to show up as part of different problems. Okay, so in this equation, if we plug in c like we're normally supposed to, what we would get is 0 over 0. Okay, you can check that if you want, but if you plug in c for all of the c's in this equation, at some point everything would cancel, or we get something over 0, which is not good. So our job is to cancel stuff out. So if you can tell, There's a positive 3x squared and a negative 3x squared. Those cancel each other out. We have a negative 3x right there and a positive 3x right there. And we have a positive 2 and a negative 2. So all of that stuff just canceled out. And now we have the limit as c approaches 0 of 6xc plus 3c squared minus 3c all over c. Make this stuff smaller. And if we factor out a c from the top and the bottom, or from the top rather, we get the limit as c approaches 0 of c times 6x plus 3c minus 3 all over c. Common factors cancel, right? C over c is just 1. And then we get the limit as c approaches 0 of 6x plus 3c minus 3, which is just 6x minus 3. Right, if we then plug in this 0 into this c, that's 6x plus 0 minus 3, so this is our answer. Okay, I showed a lot more work than I probably need to show. Normally, if I were doing this kind of on my own, I probably wouldn't show like this step. I'd probably just kind of multiply that out. And then I'd probably cancel. So that's pretty much the only step that I wouldn't show. But that's how we do that. Okay. Same thing is true for number 2 and number 3. It's just going to require different things to do when we're trying to cancel stuff out. Okay. So that's number 1. Also, just as a, again, not a warning, just kind of a detail. These 3 are probably going to take you the longest, with the exception of maybe number 12. Everything else should be relatively straightforward. All right. So number 2, I'm going to do number 2 on the right. We have y is equal to negative 1 divided by 2x plus 1. And we're going to do this same exact thing. So we need the limit as c approaches 0 of f of x plus c, which is going to be negative 1 over 2 times x plus c plus 1 minus f of x, so minus a negative 1 over 2x plus 1 all over c. So I'm going to clean some stuff up here. And now we have something that looks a little bit intimidating. We have a fraction within fractions, and we're adding on top, and nothing's happening on bottom, and there's a negative thrown in there and all that stuff. Okay. But whenever you see a fraction adding to a fraction, you just got to remind yourself of how to do that. For example, if we wanted to add 3/4 to like 1/7, okay, we would multiply that left fraction by 7 over 7. And this right fraction by 4 over 4. So we're just going to take the opposite denominator and multiply it out. So what we're going to do on this right side, we're going to multiply this right side by 2x plus c plus 1 over 2 times x plus c plus 1. Right, and on this left side, this is going to look a little bit weird, but 2x plus 1 over 2x plus 1. We're going to carry out that multiplication, and then we're going to add those fractions together and see what happens. Okay, so what we're going to get, the limit as c approaches 0 of negative, and then 2x plus 1, right? 2x plus 1 times 1. It's just 2x plus 1, and then there's that negative out front. On the bottom, I'm going to write this as 2 different factors. So we get 2x plus 1 times 2 times x plus c plus 1. We got second. Congratulations. I'm glad you guys are doing so well in Fortnite right now. And then we're going to do the other fraction. So we have 2 times x plus c plus 1 over the same denominator we had on the left. And this is all going to be over c, which I know that this is more intimidating to look at, but we're going to simplify some things here. So I'm going to go back to green. So we have the limit as c approaches 0. We have this negative 2x plus 1, which is negative 2x minus 1. And then we have a positive 2x. So I'm going to write this out. So negative 2x minus 1. That's this thing right here. We're adding this stuff, and we can do that because they have the same denominator now. So we're going to add 2x plus 2c plus 1. This whole thing is going to be over 2x plus 1 over 2 times x plus c plus 1. And this is all over c still. And we're going to cancel stuff. So if we cancel stuff, there's a negative 2x, there's a positive 2x, there's a negative 1 and a positive 1. So now we have the limit as c approaches 0 of just 2c over those two factors. All over c. Which is really equal to 2c over c times all this stuff. And then those c's cancel, and then we can plug in our limit. So really what we're asking when I asked all this is we're taking the limit as c approaches 0 of 2 divided by 2x plus 1 times 2x plus c plus 1. And now we can actually take this limit. Okay. So when we plug in 0 for c, we're just left with 2 divided by 2x plus 1 times 2x plus 1. That's our answer. And there's that negative up front that I've been neglecting. Nope, there's not. Never mind. Yeah, okay. So why is that all times c? So you're talking about from this step to this next step. So when we divide by something, right? So if we divide by a fraction, again, I'm going to keep this simple. So if we have like 4 divided by 5 over 4, let's say. So we have 4/5 divided by 4 over 1. This is the same thing as 4/5 times 1 over 4. So this should just be 1/5. Okay. So down here, this is like c divided by 1. So when we're dividing by that fraction, we're really multiplying by that reciprocal. So this c just kind of comes into this denominator. So you can just pull that c from the pull the c from the denominator to the yeah. If it's just again, just keep this simple. So 4/5 divided by 4. This is the same thing as, so 4/5 all divided by 4. This is the same thing as 4 divided by 5 times 4. Those are the same thing. I hope that all makes sense. I know that's a lot of work. Again, some of this work you don't really have to show. I'm just trying to show you step for step. But that's what I'm expecting. Your brain hurts. That's okay. It's not easy. But I hope your face doesn't hurt either. 'Cause it's been killing me lately. All right, anyway. Next one. So again, we're going to do the same thing. We need the limit as c approaches 0 of f of x plus c minus f of x all over c. In this case, this is going to look like limit as c approaches 0 of f of x plus c. So this is going to be 4 times x plus c plus 4. We're going to subtract the square root of 4x plus 4. That's mean. Yeah, I know. I'm sorry. F of x plus c minus f of x all over c. So now we have this. This looks a little bit more harmless, but we still have that c in the denominator. But in this case, now that we're dealing with radicals, we can rationalize. Okay. So what we're going to do is we're going to multiply by the conjugate of that numerator. So that's going to look like square root of 4 times x plus c plus 4. And instead of minus here, we're going to make that plus, and then we're multiplying by the conjugate. Everything else stays the same. And we can only ever multiply by 1, so we're going to do this. Now, when you do this, again, this looks more intimidating than it actually should be. And I come down here. If you multiply something by its conjugate, what you get, if you FOIL this out, and you can FOIL this out on your own if you don't trust me, but what you're going to get is you're going to get a squared minus b squared. Okay, so through all the FOILing, all the middle terms cancel, and you're just left with the outer terms squared, and you're subtracting them. So if we multiply the top together, we're just going to get this thing squared and then this thing squared. And we're going to subtract those two things. Okay, so we get square root of 4x plus c plus 4 squared, which is just 4 times x plus c plus 4. And we're going to subtract 4x plus 4, the square root of 4x plus 4 squared, which is just 4x plus 4. And then in the denominator, we just have c times all that stuff. And then now we're just trying to simplify a bunch. So we get the limit as c approaches 0 of 4x plus 4c plus 4 minus 4x minus 4 all over that denominator. in the numerator, you have things cancel. 4x cancels negative 4x, positive 4 cancels negative 4, and you're just left with that 4c. So what we end up getting is we get the limit as c approaches 0 of 4c divided by c times all that other stuff. Four c divided by c, that's just 4, right? So those c's cancel. So we get the limit as c approaches 0 of 4 divided by square root of 4 times x plus 4 plus c. Sorry, x plus c plus 4. Plus the square root of 4x plus 4. And now we can just plug in 0 for c, and we're going to get our answer. Okay, so when we plug in this limit, this c limit, into c, we're going to get 4 divided by 4 times x plus 4 plus 4x plus 4. So we're going to get 4 divided by 2, 4x plus 4. Okay, I kind of skipped a step there. Basically, the c just becomes 0, so you're left with the square root of 4x plus 4. The square root of 4x plus 4 plus itself is just 2 times that thing. So then this is our answer. I'll leave that up for a second because I feel like that might be a little bit confusing. Okay. So it's a little bit tedious, I understand that, but we need to be able to take the limit definition of a derivative because that's something that's important. It's just a application of slope. Okay. So number 4 through 7, this is just taking the derivative, but now we have these rules to help us. Okay. So some rules that show up, for instance, the derivative of a constant. So I'll make this a number. That's just 0, right? If we graph the line y is equal to 4, we have a horizontal line. The slope of that is 0. Hence, the slope of 4 is equal to 0. Okay. Constant multiple. So let's say like 5x. That's just equal to 5. Then we have the power rule. Like x cubed. That's equal to 3x squared. The derivative of sine is cosine. The derivative of cosine is negative sine. That's and then the derivative of e to the x, just e to the x, right? And these can all interact with one another. So we're using all these rules, and then the sum or difference rule, which just says that the derivative of a sum or difference of things is the sum or difference of those derivatives. So it's essentially just the same thing as the properties of limits. All right, these are just most of them written out. So use the basic rules of differentiation. That's this stuff up here, plus like one more. to find the derivative of the following. So we need f prime of x for all these things. And I'm going to try and write these out the best I can. So I'm going to make this a little bit smaller. I'm going to make everything else bigger. Okay. So we're going to do this step at a time. Okay, so we want to find the derivative of f of x, where f of x is 3/4 times the sine of x plus 1/2 x to the fifth minus 7/2 x cubed minus cosine of x. Okay, in order to do that, we're going to split it up into different pieces. So we're going to get f prime of x by taking the derivative of each of those individual pieces, right? Where the first piece is 3/4 sine of x. Right, so we're going to use a combination of the constant multiple rule and the sine rule. Okay, so we're going to get 3/4 times the derivative of sine, which is cosine. So we're going to get 3/4 cosine of x. That's that part in blue. Okay, then we need the derivative of this middle piece, so 1/2 x to the fifth. So the derivative of 1/2 x to the fifth, we're going to take 1/2 multiplied by 5. That's 5/2. And then we're going to subtract 1 from the exponent. So that's that second piece. Third piece is very similar. We're going to multiply 3 by negative 7/2. So we get negative 21 over 2. And then x, and then we're going to subtract 1 from the original power, so it's going to be squared. And then we take the derivative of negative cosine. So the derivative of cosine is negative sine. If we take the opposite of that, we just get sine. So plus sine of x. Right, so this is really 4 problems into one. We're just putting it in different pieces. Okay, so again, derivative of 3/4 sine is going to be 3/4 times cosine. The derivative of 1/2 x to the fifth, we're going to take this 5 multiplied by the 1/2, so we get 5/2. And then times x to the fourth. So we're subtracting 1 from that power. Same thing for this part in green. We take the exponent of 3, we multiply it by 7/2, we get 21 over 2. And then we're going to subtract 1 from that exponent. So it's going to be x squared instead of x cubed. That part in blue, the derivative of cosine is negative sine, but there's that negative out front, so it's just going to be positive sine. Okay, this next one is probably the one that takes the most thinking. I'm going to write this as x cubed over x squared minus 4x squared over x squared, and then plus 3 over x squared. If we simplify that, we get x minus 4, and then plus 3x to the negative 2. And then once we get there, we're going to do the exact same thing we did before. Okay, so we're going to take the derivative of x. All right, so f prime of x is equal to the derivative of x, which is just 1. The derivative of negative 4, which is 0. And then we're going to use the power rule on 3x to the negative 2. So this is going to be negative 6x to the negative 3. And then this is fine for your answer. If you wanted to, you could write this as 1 minus, I guess. 6 over x cubed. So either one of these boxes will do. They're both the same thing. Number 6, kind of similar, right? So I'm going to rewrite this as f of x is equal to 5 times x to the negative 2 minus 4x to the 5/9. Okay, so again, we're just taking derivatives of each of these pieces. The derivative of 5x to the negative 2, that's going to be negative 10x to the negative 3. And then we have a fraction, but it still works the same way. So we're going to take this exponent, we're going to multiply it by our constant coefficient, and then we're going to subtract 1 from that exponent. So negative 4 times 5/9, that's negative 20/9. And then we have x, and then 5/9 minus 1 is going to be negative 4/9. Then that's our answer. Again, you can write this in different ways. So this is the same thing as negative 10 over x cubed minus 20 over 9x to the 4/9. Okay, either one of those will do. My guess is the top one is where people are going to stop, but they're both right. Same thing for number 7, just to throw in a couple of things at you. Derivative of negative, write this first, so g prime of x. The derivative of negative x squared, that's negative 2x. The derivative of negative 7 e to the x is just negative 7 e to the x. The derivative of 4 sine of x is 4 cosine of x. And then the derivative of negative 9, that's just 0. So then this is our answer. So this kind of, the crutch here is that we know these things. Okay, if we know these things, this should be really, really quick. Maybe a little bit of thinking here, but it should go, like these should be some of the faster answers that you do. The only thing where you have to think kind of is rewriting the equation right into this stuff, or rewriting the equation into that stuff. Got the dub. Congrats, Jack. Glad you won Fortnite. Um, 8, 9, 10, and 11, this is very similar to the last test. Okay. Limit as x approaches negative infinity of 15 over x squared plus 5. Basically, we're just taking negative infinity and plugging it in, kind of. Right, so if we think about this, negative infinity squared, that's going to be positive infinity. Positive infinity in the denominator makes the denominator grow faster than the numerator. So if our denominator is growing faster, our entire fraction is going to 0. Again, a negative infinity. So this would be like negative infinity cubed minus 3 times negative infinity squared plus 6. Okay, negative infinity cubed, this is still negative infinity, minus 3 infinity, and then plus 6. Okay, so this whole thing is going to negative infinity. A lot of negative infinities. I'm not sure why that came out like that, but that's okay. For number 10, again, just think about this. In this case, this constant really doesn't matter when we're dealing with infinity. So we have negative infinity squared over negative infinity squared. Those kind of like cancel. Not exactly, but they kind of do. So we're just left with negative 2. Same thing on number 11. These negative infinity squareds kind of cancel. The 9 doesn't make a whole lot of sense when talking about infinity, so this is just going to 1. Right? Negative infinity over negative infinity is just 1. So that'll be our answer. People seem to do really well on this on the last test. Just expect the same thing. And then this comes to probably the longest question on the test. If you know how to do it, if you know how to do the ones like up here, this shouldn't be a problem. Write the equation of the line tangent to the given function at the given point. You may use decimals rounded to the nearest tenth. Okay. So first thing we need to do is think about what this is actually asking. So we need the equation of the line tangent. So we need some form of y equals mx plus b, or y minus y1 is equal to m times x minus x1. Regardless of what we do, we have to find slope. That's the derivative, or the slope of the line tangent. And we have to have some point as a basis. Okay, so let's find that point right now. I'm going to give you the second half of this point on the test, but for now we have to find it. So when we plug in 9 into h, I'm going to plug this into a calculator, but I'm just writing this out so we know what's happening. So 3 times 9 to the 1/2. Minus 5e to the 9th. Minus 2 cosine of 9. When we plug that in, we get out negative 4,000 or 40,504. And I'll round to the nearest tenth, like the directions say, which is 0.6. Okay, so we have this xy point. We have 9 comma this. Okay, so that's our point. The next thing we need to do is we need to find the derivative so we can find the slope at that point. So we need to find h prime of x. And we're just doing like what we did up above. Okay, so the derivative of 3x to the 1/2, right? We take 1/2, we multiply it by 3. So we get 3/2 x. And then 1/2 minus 1 is negative 1/2. So x to the negative 1/2. The derivative of negative 5e to the x is just negative 5e to the x. And then the derivative of negative 2 cosine of x is just sine of, or 2 sine of x. So plus 2 sine of x. Okay, so this is the equation in order to find the slope at any x point. Okay, so now if we plug this in for 9, we're going to get the slope at 9. So we would plug in 3/2, 9 to the 1/2, minus 5e to the 9th, plus 2 sine of 9. There should be a negative 1/2 there. And when we plug that in, we get negative 4514.1. Okay, so this is our slope of this equation at 9. So we have a slope now. And we have a point. So we have a point and a slope, so we could plug that into point slope form. So we'd get y minus our y1 value. So this would be plus is equal to m times x minus x1, which is just 9. Okay, so there's a little bit of thinking just to make sure we know what you're doing. Okay, the first step, which I'm going to give to you, so I'm doing this part for you. I'm giving you this point. You have to find the derivative in order to find the slope of your line. So this is the slope of our line. Okay. And then we plug that into the equations that we know for finding lines. Okay. Again, I think this is the hard part of this exam. Everything else should go pretty smoothly. But number 12 is, it's asking you to apply the derivative stuff instead of just asking you to find it. Okay. So that's number 12. I'm going to move on. This page is going to be exactly like the quiz and exactly like the last test. So I'm just asking you to evaluate some things, right? F of 3. That's going to be 2. F of 10. Looks like it's going to be 9, right? It's the full circle that we're looking for, so 9 is our answer. The limit as x approaches 10 from the left, that's this guy. So it's approaching 9 from the left, but from the right, it's approaching 4. Are you able to find the tangent with only a y value? I'm hoping you mean x variable. Right, so we found the point, right? So this is the point. We found the tangent by plugging that point into the derivative. So you have to find the derivative first, and then you plug in the point that I gave you. Okay, so again, I'm going to be giving you this thing right here. This is going to be given to you on the exam. Your job is to find the derivative, plug in the x value of the point I give you in order to find the slope of our line at that point. So that stuff in blue, that's what I'm asking you to get. Right? Find the derivative, plug in our point, and that gives you the slope. Right? Remember, that is the slope. So that's m. I hope that makes sense. So again, the stuff you're not going to do. I'm going to give that to you. But that's just finding the point, which shouldn't be very hard anyway. Okay. All right. So going on, limit as x approaches 7 of f of x. So that's from the left and the right. From the left, we are approaching 6. From the right, we are also approaching 6. So that answer is 6. Label and classify all discontinuities. I think we were pretty good at this. We have a discontinuity at 7. That's removable. We have a discontinuity at 10. That's not removable. We have a removable discontinuity at 13. And then at 16, we have this unbounded behavior. Okay, so that's number 6. Keep in mind, don't just label them, or don't just classify them I'm making sure that it's so I guess what I should do. X equals 7. This is removable. X equals 10. Differing behavior. That's what I should have written. X equals 13. Removable. And X equals 16. Unbounded. Label all points that are continuous but not differentiable. Okay, so differentiable has to have, it has to be continuous at that point, and it also has to be a smooth and curved line. Okay, the only place that this isn't smooth and curved is X equals 3. Right, so you're looking for sharp edges. Right, so there's other places where it's not differentiable. It's not differentiable at all the discontinuities on number 6, but it's also not differentiable at 3. That should be 3, not 13. Okay, and that's that second part of the test. Okay, going on from here, we're almost done. Solve each equation, right? So logs. What about x equals 1? Oh, that's unbounded too. I just missed that. So that should be unbounded behavior too. My bad. You're right. It's unbounded. Unbounded. Okay. So number 1, 2, and 3 all have to do with kind of that first chapter. So there's going to be 2 log questions. That's number 1 and 2. And then there's going to be an inverse question, right? So I'm going to let you go back to the log videos and look up these properties. I'll try and explain the ones that are important here, but they might be different on the test. So just so we know them. We have the difference of 2 logs here. So we need to combine them. So this combines into the log of x squared plus 1 divided by 5 equals 1. In order to undo the common log, right? So when there's no number here, it's assumed to be 10. In order to undo this log, we have to take everything to the power of 10. Or take everything as an exponent of 10. And what we do on the left, we have to do on the right. So what this does, this 10 to the power of log, that cancels, and we're just left with x squared plus 1 over 5. And now 10 to the first, that's just 10. And then this is just a simple algebra problem, right? We multiply by 5 on both sides. So we get x squared plus 1 is equal to 50. Subtract 1. We get 49. Take the square root of that. Get plus or minus 7. Number 2 is kind of the inverse of that. Right, we have an exponential. All right, so I'm going to, I'll write operations on x just so we see it. You don't have to do this. I just like doing this because it makes sense. Right, the first thing that happens to x in number 2 is we multiply by 2. The next thing is that 2x is being taken as an exponent of 10. Then that 10 to the 2x is being multiplied by 2. And then we're adding that 3.2. So in order to solve for x, we're going to reverse the order and invert the operation, right? So the first thing is we're going to do the inverse of add 3.2. So we're going to sub 3.2. So this is going to be 11 minus 3.2. We're going to multiply that. We're going to divide that thing by 2. The inverse of exponential of 10 is going to be log base 10. So that's going to give us log base 10 of 11 minus 3.2 divided by 2. And then the last thing we have to invert is multiply by 2. So we're going to divide all of that by 2. And then this can be your answer. You can get a decimal like it says here. I'm not really worried about it. This in green tells me you know exactly what you're doing. So that's what I care about. Okay, when you do that, so when you plug it into a calculator, log 11 minus 3.2 divided by 2, all divided by 2. You get 0.03 or 0.3. Now, you need to show your work, so I'm expecting some kind of solving for x here, not just 0.3, but you get my point. Just so people are comfortable, this is 0.295532 and so on. And that rounds up to 0.3. Three is pretty much the same thing. Okay, find the inverse, so we're swapping variables and we're solving for this thing. Sorry, we're solving for n. Okay, so I'm going to do this again, right? Operations on n. We subtract 3. That gives us n minus 3. We need that in the denominator, so we need to flip that entire thing to get 1 over n minus 3. Then we need to multiply that by 3. So we get 3 times n minus 3. 3 times 1 over n minus 3. And then we subtract 2. So in order to get the inverse, we have to add 2. So we get n plus 2. We have to divide by 3. So we get n plus 2 divided by 3. We have to flip that. So we get 3 divided by n plus 2. And then we subtract 3. And that'd be our answer. Okay, so that's the test. I'm going to leave this open for a couple minutes. I do have to get to my honors pre-calc one, but I want to answer any questions you have first. So I'm going to leave this open for a couple minutes. Please let me know if something on here didn't make sense. I understand this is long. That took me about a little under an hour to kind of write everything down and explain every part. So this should be doable, but I want to make sure people understand it before they go into tomorrow. So I'm going to mute myself for a second, look through this. I'll kind of start at the top and scroll down. If there's no questions after that, I'll end it, and we'll see you tomorrow. But for now, look through this, make sure it makes sense, and I'll answer anything I can. You're welcome, Daniel. Can you get a shout out? I don't know. I don't know if I should shout you out. Donate $10,000 and I'll give you a shout out. And you're welcome, Joe Yu. I don't know who you are, but you're welcome. I think I did at some point. I don't know who you are now though. That makes sense. The apple bomb. I don't know what 10K social credits mean though. There's your donation. What does that mean? $10,000. I'm not. I want currency, not social credit. 10K in lottery tickets. I would take 10K in lottery tickets. or 10,000 lottery tickets. 10,000 lottery tickets is more than 10K in lottery tickets. So, okay. All right. The social credit system is an extension of the risk assessment credit rating system that were introduced in China in the 1980s. I don't know any what that is. I know math. That's and Russian history, kind of. I'm guessing you meant proponents. Proponents argue that it will help eliminate problems such as food safety issues, intellectual property theft, violation of labor law, financial infidelity, and counterfeit goods. I'm assuming it didn't work. That sounds like a corrupt thing. It's credit score, but not ours. Okay. It doesn't seem like anyone has any questions over like math, so I'm gonna close this in the next minute. If you have questions, please come in. I'm gonna try and be there at about 8 o'clock, if not a little bit before. You can ask me questions then. The test is gonna look exactly the same. The numbers and equations will be different, but it's gonna be the same order, types of questions, all that stuff. Okay. Um, have a calculator, have that stuff ready, um, and you'll be good to go. All right. Look over your previous tests. That'll help. Look over logs. That'll help. There's other videos over logarithms. Just make sure you're able to solve them. It's essentially just taking the inverse. So if you know how to do number 3 that you're looking at right now, and you know the inverse of an exponential and a log, you know how to do logs. Okay. Um, so I will see you guys tomorrow. Good luck. If you have questions, please let me know. And we'll take this exam. All right. So thank you, and I will see you tomorrow.